This is assignment 7-1. This is a pre-calculus assignment, but I think there's some review questions in calculus. It's all about exponentials. So can you simplify these without a calculator? 8 to the 2/3. This is the cube root of 8, and then you square it. So the cube root of 8 is 2, and then 2 squared is 4. So understanding the denominator is the root, the numerator is the power, and go one step at a time. I'm just going to write them down right here. Oh, that's upside down, isn't it? So there it is. Number 2 is 25 to the negative 3/2. So again, the square root, the denominator of the fraction is square root. That's 5. And then 5 to the exponent negative 3. The negative exponent means reciprocal, and 5 times 5 times 5 is 125. So it's 1 over 125. Number 3, 3 to the 0, subtract 5 to the 0. That answers 0, because any number to the exponent 0 is equal to 1. So it's 1 take away 1, which is 0. For number 4, same, 3 take away 5. Again, any base to the exponent 0 is equal to 1. Number 5, 4 divided by 4 cubed. If the base is in the same and you're dividing, subtract the exponents, or another way to write that is 1 over 16. Number 6, 3 to the negative 2 to the negative 1, just trying to get it all tricky like with negative exponents. So inside the parentheses is 1 over 9, and then to the exponent negative 1 means you do the reciprocal of that. So 3 to the negative 2 is 1 over 9, and then the negative 1 exponent means you do the reciprocal of that. Number 7, 3 to the negative 4 times 9 to the 3. We're going to get common bases here to combine this together. So 9 is 3 squared, and there's already a 3 in the exponent. So 2 times 3, that's 6. And now when you multiply, you add the exponents, so that's 3 squared. So do you know your exponent laws to simplify? Number 8, 8 squared divided by 4 cubed, get common bases. 8 is 2 cubed. 4 is 2 squared. Remember, the exponent that was there before multiplies the new exponent. So it's 2 to the 6 divided by 2 to the 6. That's 1. Number 9. These are just pre-calculus practice question with exponentials. 2 over e to the negative 3. So the negative exponent means reciprocal. The exponent 3 belongs to both, and you have your answer. Number 10. Oh, I can do this side. E, negative e squared over e to the negative 2, and that's squared. Make sure I wrote down the question right. So inside the parentheses, when the bases are the same, you subtract these. So 2 subtract negative 2 is 4. So it's negative e to the positive 4. And then multiply the exponents together. So I get negative e to the 8. Oh, and because you're squaring, this becomes positive. So because you're squaring and the negative becomes a positive. So it's positive e to the 8. Number 11, e squared times e to the negative 1 over e to the negative 4. Remember, e in math is a number. So start with the numerator. When you're multiplying in the bases, add the exponents. It's e to the 1. When you're dividing, subtract. So 1 subtract negative 4 is e to the 5. And then multiply. Know your exponent rules. Number 12, the last one of these. E plus 3 squared means I'm going to FOIL. So there's no rule here. This is e plus 3, e plus 3. So if you FOILed that, you get e squared, 3e and another 3e. And then 3 times 3 is 9. First, outer, inner, last. Combine like terms. And you have e squared plus 6e plus 9. Number 13. And number 13, you're solving an exponential equation. 2 to the x equals 16. You can get common bases or just know the answer. So for this one, x would have to equal 4 because 2 to the 4 is equal to 16. For number 14, get common bases. That will make it easier. So 27 can be written as 3 cubed so that the bases are the same. Then make the exponents equal to each other and then solve it. Again, all of this is pre-calculus work. Number 15, make the bases the same. So 1/2 is 2 to the negative 1 times 2x. 8 is 2 cubed. And then once you have the bases the same, then just make the exponents equal to each other so that you can then solve it. Number 16, x to the 4/3 is equal to 16. Right? Yeah. Okay. So to undo a fractional exponent, it's the reciprocal. So the reciprocal is to the exponent 3/4. The reciprocal undoes the fraction, so it's just x. And then what does this mean on the right side? The 4th root of 16 is 2. And then 2 cubed is 8, and you have your answer. Number 17. You have e squared over e to the x cubed equals e to the 9th. Is that what we got? So how will we solve this? So to get write this as 1, you're going to subtract the exponents. And then that 3 distributes. So it's 6 subtract 3x. And then once the bases are the same, you make the exponents equal to each other. So I'm going to subtract 6 and then divide and then get my answer. Number 18. 5 subtract e to the x equals 1. So x must equal 0 because anything to the exponent 0 equals 1. Ha, that was quick. Number 19. It's different, not an equation. What's 19? So 19, we're going to do a graph. So can you graph y equals 2 to the x? And it says, right in the sketch a graph, list all intercepts and write an equation. Use a separate coordinate plane for each graph. So what we're really going to do is just use 2 points. So for the first one, 2 points in an asymptote. So what are 2 points on this graph? Move the arrow here. So 2 points on this graph would be 0. 2 to the 0 is 1. So 0, 1 would be on this graph. And then the other point would be if you plugged in positive 1, you get the answer 2. And then there's an asymptote. Let's see where that is. I have a highlighter somewhere. Here it is. So there's an asymptote for an exponential right there at 0. And then what does the curve look like of this? And so that's the curve of an exponential. So you have 2 points and the asymptote. Number 20, I think it's y equals 2 to the negative x. So again, we're going to find 2 points on this. So if I plug in 0 for x, the answer is 1. That didn't change. If I plug in positive 1, you actually get a half. So it's actually a declining or decaying function. A negative 1 would give you the answer 2. So this is the direction of it. The asymptote is still at 0. And there is the function. 21 is y equals, let me do that on this page. So 21 is y equals negative 2 to the x. Again, we're going to find 2 points in the asymptote for this. So 1 point for this one. Again, if you plug in 0, but this time if you plug in 2 to the 0 is 1, so the answer is actually negative 1, so it's below. So that negative, when you do order of operations, you do exponents first and then the negative. If I plug in positive 1, it's 2, but it becomes a negative 2. So 1 and negative 2. The asymptote never changes. The only thing that changes the asymptote is if there's a number adding or subtracting. It's what we call the k. So the number at the end, adding or subtracting, we have hk. That's what changes the asymptote. So nothing adding or subtracting at the end. It's 0. And then what does the curve look like? That negative creates a reflection. And then you have your graph that looks like this. So it's been reflected down. Number 22 is, what is that? Y equals 2 to the x plus 1. So here's an example where it's been shifted to the left one. So again, I'm just going to get 2 points. If I plug in 0, I get 0 plus 1. So it's 2 to the 1. So 0, the answer is 2. If I plug in negative 1, negative 1 plus 1 is that gives me the answer 1. So it's all been shifted 1 to the left. So the 2 points I would use has been shifted. But the curve, even though it's been shifted, has the same picture to it. But just recognize that we have a point at negative 1 and positive 1 and 0 and 2. It's been shifted to the left. 23. Now what's happening to the graph? Notice now we have something adding or subtracting at the end. So that changes where the asymptote is. So now the asymptote is below. It's at negative 1. And all the points have been shifted down 1. So if you plug in 0, the answer is 0. It's been shifted down. If you plug in positive 1, it gives you the answer 1. So everything's been shifted down 1. But that curve, in terms of the picture, looks the same. There's the curve of an exponential. And again, this is what affects the asymptote. 24. This is the last of the graph. It's y equals 2, and then we have the absolute value around that. So how do I handle that? It's a little unique, so let's just talk about it real quick. So if I plug in 0, the answer is 1. That's not unique. If I plug in positive 1, the answer is 2. And on the right, it stays exactly the same. But what happens on the left is if I plug in negative 1 for x, it changes to positive 1. So in other words, negative 1 gives me the answer 2. And so the picture here is matched by the picture here. So that's what the picture is going to look like with absolute value, because it changes all the negative x's to positive x's. So it creates a symmetry over the y-axis. And we don't even think of it as an asymptote because the end behavior for both sides is going to infinity. 25. Now I think we have some calculus questions. Here we go. Find the average value of that function. So here we are. Those were the lesson questions, reviewing exponentials. Find the average value. That's an integration question from -2 to +1. And I'm going to integrate that function. So I'm going to write it as 2 subtract x to the -1/2. And then I subtract the difference of the bounds. So this is what it looks like. So it's not just the setup. I actually have to do this work. But you integrate and then subtract the difference of the bounds. There's a hook here. The hook, the derivative of 2 subtract x is -1. So I need a negative in front so I can unhook this. And now all I have to do is add 1 to the exponent and then the reciprocal. And again, I'm substituting in from -2, -2 to +1. 1 subtract -2 is 3. So we have a fraction in front. I'm just going to write that fraction as -2/3. And then I'm going to plug in. So first I'm going to plug in +1. 2 take away 1 is 1. 1 to any exponent is 1. Then I'm going to plug in -2. Well, 2 subtract -2 is 4. And then 4 to the half is the square root of 4. And there it is. And of course, if I really wanted to simplify it all the way through, the answer would be +2/3. 26. Again, these are review questions, which makes them the most important questions of the assignment. Sketch the region x equals y squared subtract y and x equals 0. And then find the area of it. All right, so what would I do to sketch it? This is awkward because it's x equals and not y equals. So the first thing I would do actually is factor. And if you factor this and make it equal to 0, you are finding the y-intercepts. So we have a y-intercept at 0, and we have another y-intercept at +1. Now, this is a sideways parabola that's going to the right. So it's sideways to the right. These are 2 points on that. So somewhere here to the left, we have the, it doesn't even actually matter where that vertex is. It's not going to affect the answer, but I know it's to the left, and I know this is how it folds. The second is x equals 0, which is the y-axis. So if I shade in, what's this area here? That's what I'm looking for. So to find the area, that pink area, it's an integration question. Because it's y, we're going to go right, subtract left. It's the y values we use for the limits. So the lower y value is 0. The upper y value is 1. And then it's right. Now the right side is 0. Subtract the left, which is y squared, subtract y. And that would give you the area. And does it ask you to actually find the area? So let's then do. So this is the work we need to do. So to integrate this, this is -y squared. So it becomes -y cubed over 3. A negative times a negative makes it positive. And again, add 1 to the exponent and divide. And the limits go from 0 to 1. Then we plug in the upper limit. I'm not going to reduce this down. And then we subtract and we plug in the lower limit. Now when you plug in 0, it's obvious the answer is 0, so I don't even need it. And there's your answer. That's the area of that region. Number 27. In 27, f at x equals x cubed. Find the value of c from -2 to 0, where the derivative is equal to the slope formula. Hey, that's a rock equals I rock. So we're that's called the mean value theorem. So let's do that. So For the mean value theorem, first I find a rock. You could find I rock first, but the average rate of change is, these are the x values. So it's y2 minus y1. So we're going to plug -2 in, subtract, plug 0 in, and then subtract the difference of the bounds. Here, actually I put the order wrong. So 0 is greater. Ha. So it's 0 cubed, subtract -2 cubed, and then 0 subtract -2. That's how the order goes. So y2 minus y1, x2 minus x1. To find the y value, you plug in to find it. So this is -8, but the negative and the negative makes it +8 over 2. So the a rock is equal to +4. The I rock is the derivative. And so the derivative of that is 3x squared. So I take 3x squared equaling to 4. And then I solve for x. So I'm going to divide by 3. Now, you don't have to simplify it. So the square root of 4 over 3 is fine as an answer. Know the answer could be positive or negative. But know my interval. So it goes from -2 to 0. So the only correct answer is -√4 over 3. Because that is in my interval. Positive √4 over 3 is not in this interval. So what is the C value? And that's the answer. You could also write the answer like this or like this, however you think it's prettiest. But they all mean the same thing. So it's just the negative answer we're looking at. All right, number 28. In number 28, let me scroll up here. Integration question. So number 28 is the fundamental theorem of calculus, the sequel. So it's just a substitution question, but remember the hook on of it. So derivative undoes it. So we substitute in the upper limit first. So just substitute that in for x. Subtract. Now you substitute the lower limit. And then you just have to remember the hook on. So the derivative of t is 1, so that there was no hook on. But the derivative of -t is -1, and that's essential, and you have your answer. (29) Again, fundamental theorem of calculus question. So it's a substitution question, and the limit creates a hook on. So it's not a trigonometry question as such. It's just a substitution question. So the upper limit, put that in for t. Just remember that there's a hook on because the derivative of x squared is 2x. When you plug in a constant and take the derivative, it's 0. So we don't need to go subtract 0 and it's over. Number 30. Again, fundamental theorem of calculus question. It's a substitution question. So we're not going to make this complicated. Oh, it's not. It's not a fundamental theorem of calculus question. Sorry. It's just derivative. There's no integration there. My bad. So don't assume. There's no integration, so let's just take the derivative of that. So we're going to rewrite this calculus friendly. That's x to the 1/4. And then we are going to, that's a monomial. So we can simplify it. So that's x over x cubed. That's x to the -2. And that's -2 x to the -3. I know it takes some skill. But can we write it properly? So that x cubed and x, there's a 1 there. So 1 take away 3 is -2. And -2 over x cubed is this. You can see it. Now we can just add 1 to the now we can take the derivative. We're not adding 1 to the exponent. Take the derivative. So that means multiply and subtract. There it is. Don't forget the negative sign. So multiply. That's -2 times x. Subtract 1. Multiply. That's 6. And subtract. And there's your answer. No plus c. We're just taking the derivative. All right, what number are we at? Number 31. We're given a function, and it says take the derivative. So again, I'm going to write it calculus friendly. So I'm going to write it 3x squared subtract 8 to the 1/2. And I need to take the derivative at 2. That's what the question is. So first the derivative, then plug in 2. So the derivative of this would be the product rule. That's the first times the derivative of the second. So take the derivative of the second, and then there's a hook on of 6x. And then plus the second times the derivative of the first. So the first is x. You don't need to go times 1. And then you plug 2 in. I'm actually going to do that down here so I have room. So plug 2 in wherever you see an x, and I'm not going to make you simplify that. Oops. Plug a 2 in where there's an x. And there's your answer. And again, the only reason you would simplify this if it was multiple choice, and then you'd work at it and do it. Otherwise, you'd let this go if it's free response. Number 32. 32. So the square root of 3 to 2. Make sure I got the question down. So this is an integration question. Again, I'm going to write it calculus friendly. And can you do the integration here? So the first thing I notice is the derivative of this is 6t. So then I have to undo the 6, so I have that fraction. Then you can unhook this, and it starts with 1/6, and then add 1 to the exponent. This is to the 1/2, right? Did I do that? Square root? Yeah. All right. So add 1 to the exponent. That's 3 over 2. And then the reciprocal, which is 2/3. And then we're integrating from -3 to 2. If you like, you can reduce this down. Not necessary. So 2 does go into 6. This is 1/9 or 2 over 18. And then we plug in the upper bound and then the lower bound. So the upper bound is 2. And then the lower bound is √3. So that's a perfect answer that way. If you needed to simplify it, let me do it for fun. 12 take away 8 is 4. √3 squared is 3. So it's 9 take away 8, which is 1. I love that number. So the square root of 4 is 2. 2 cubed is 8. Any number, any exponent. So 1 to any exponent is 1. So this is just -1/9. So it's 8 take away 1. So it's 7 over 9. Is that right? Yeah. So only necessary if it was multiple choice. That was just for fun. My idea of fun is different than your idea of fun. Number 33. We're integrating. Oh, this is the one I wanted to take the derivative of almost before. So we're integrating. So it is the y to the 1/4. I'm just going to do the work I did before, which is y to the -2 and -2y to the -3. So I already did this work with x in the question like 3 questions before. It's the same one as above it. So that's how you would write it as monomials. And then integrating means you add 1 to the exponent, and then reciprocal, add 1, and then divide makes that a plus. Add 1, and then the reciprocal, and then don't forget the candy. We could simplify that if you want. That'd be 4/5 y to the 5 over 4 plus y to the -1. Negative, that would just give you plus y to the -2 plus c. Was that should this be a plus? I think I wrote it down wrong. So a negative times a negative. Yeah, that should have been a plus sign. So a negative times a negative, this is a plus. All that would change is this at the end should have been a subtract sign. All right, number 34. You have the derivative is 1 over the square root of 2x. So I'm going to write that as 2x to the exponent negative a half. Y equals 0, x equals 2. Find the equation of the curve y. So I want to know what y equals. That's my goal. So in order to know what y equals, I integrate what this is. So to integrate this, understand that the hook on for 2x is 2. And then I need a 1/2 in front. So we have 1/2. The 2 is unhooked. And then add 1 to the exponent and then the reciprocal. So that's what y equals. And then we plug in. So y is 0. 1/2 and 2, they undo each other. And x is 2, so plug in that. So this is, oops, this is where the parentheses should have gone. It's 4 to the 1/2. That's the square root of 4. And so when you solve for c, c is negative 2. So then when you put it all together, y is equal to 2x to the 1/2 minus 2. All right, number 35. In number 35, the second derivative is 10x to the negative 1/3. The first derivative at 8 is 50. And f at 1 equals 30. And this is find an equation for that curve, f at x. That's my goal. All right, so if you're given the second derivative, the first derivative is the integration of the second derivative. So if I integrate this, so I'm just going to add 1 to the exponent. So if I add 1 to the exponent, it's positive 2/3 and then the reciprocal and the candy. And it says the first derivative at 8 equals 50. So I'm going to make it equal to 50. This simplifies. So 2 goes into 10 5 times. And 5 times 3 is 15. X is 8. And then solve for c. So the cube root of 8 is 2. And 2 squared is 4. So this becomes 60. Subtract 60 and you can see c is equal to negative 10. So now to find f at x, it's the the integration of the first derivative. So we just found that. So f prime at x is 15 x to the 2/3 and then c was minus 10. And then we integrate that. So to integrate this, we're going to add 1 to the exponent and then do the reciprocal. And then 10 is just 10x and then c. And then I'm going to have to move on to the next page. Now you plug in the value for the next one. So we make it equal to 30. So this is 35 continued. So we're going to write down 30 equals and then you plug in 1 for x. So that's 1 to the exponent 5/3. So now we plug in 1 for x and solve for c. So 1 to anything is 1. This here is 9. So 5 goes into 15 3 times. 3 times 3 is 9, minus 10, plus c. So I get c is equal to 31. So if I put this all together, f of x is equal to 9x to the 5/3 minus 10x plus 31. Number 36, feel free to give yourself a break if you need to. Use the acceleration graph at the right and then find the following for an object moving along a straight path. So the graph I'm giving is acceleration. So in part A, if A at 1, just look off the graph, and now it's in the middle of that line. So I need the equation of that line to solve it. So I can't say, it's kind of something. I need the equation of it. So 2 points for that line are 0, 0. And another point for that line is 3 and 1. Right? It's 3 and 1. 3 and 5. So what's the equation of that between those 2 points? So the slope would be 5 over 3. And using one of the points, I'll use 0, 0, then you can tell that that's the equation of that line segment. So when it says what's A at 1, then you plug 1 into here, and the answer is 5/3. And then you need the unit, which is meters per second squared. So don't assume it. You might have to write an equation of a line that goes through 2 points, then plug 1 into that equation, and then you get your acceleration. Part B says, what's the acceleration at 6? So at 6, that's a lot easier. That's a horizontal line that's just 5. So that's 5 meters per second squared. Part C, what's the acceleration at 9? I can see it's positive 1 right off the graph. So this is what my work looks like so far. Number 37. Oh, I'm not. That was wishful thinking. Part D is A at 12, which is negative 2. Just reading off a graph. And if it's not obvious on a graph, you might have to write an equation and use it to get the answer. Part E what's the velocity at 3? So to find the velocity at 3, you would integrate. So the equation at 3, you would find half the base times the height. And it says, suppose the volume at 0 equals 2. So that means the starting value is 2. To find here, I'll show you my work. To find the velocity at 3, we integrate. So first of all, the velocity starts with the value of 2, and then we integrate from 0 to 3. So this is what it would look like. So to find the velocity off an acceleration, it tells you the initial value at 0 is 2, so that's the initial. And then we integrate to find the velocity from 0 to 3, and then put that all together. So off the graph, that's just a triangle. If you integrate that, find the area of that triangle. So that's half the base, which is 3, times the height, which is 5. So it's just 2 plus half of 15. So it's 9.5. And it's meters per second. Part F, I'm going to have to go to another page again. Part F says, what's the velocity at 7? Well, we already found this, that at 3, right, the answer was 9.5. So I'm just going to start with 9.5 plus. And then I'm going to integrate from 3 to 7. And if I integrate from 3 to 7, it's just a rectangle. So from 3 to 7, the width is 4 and the height is 5. So the rectangle is 4 by 5. So I'm just going to add 20 to it, and I get 29.5. So up to 3, we found the answer. So then 3 to 7, it's a rectangle, the area. It's 4 times 5, and then you put it together, and this would be meters per second. Part G says, find the velocity at 10. So again, I'm just building this up. So already at 7, the answer is 29.5. So then I'm going to integrate from 7 to 10. And again, I'm going to do that by finding the area under the curve and then see what do I add to that. So from 7 to 10. So from 7 to 10. So first of all, I see a trapezoid from 7 to 8. That trapezoid from 7 to 8, it's 1/2 times 1 times, and then the two heights are 5 and 2. And then the second shape is a triangle. So from 8 to 10, it's a triangle. And then it's half the base. So that's half of 2. And then the height of that triangle is 2. So this is what I get for that. Seeing the trapezoid and the triangle and then putting it together. So half of 7 is 3.5. Half of 4 is 2. So if I put this together, I get 5.5, 30, 34, 35. If I add it up. Can't even, like that. This is where I make a mistake, right? That's, I don't know what you call that. H. That's funny. Maybe that's what you call it. H is V at 12. So just keep going along. We already know V at 10 is 35. So now we're integrating from 10 to 12. So from 10 to 12 is a triangle, but it's going to be negative because it's below. So half the base times the height. So half of 2 times 2, but it's going to be negative. So if I do that area of that triangle to 35, and again it's negative, it's 35 take away 2. So that's 33 meters per second. Wow, that's the ability to interpret and read off a graph. Part I. At what time from 0 to 12 was the object moving the fastest? So it's moving the fastest when the acceleration and the velocity are both positive. So I would say it was moving the fastest up here between 3 and 7. Now, if I do that, so it keeps going, the acceleration keeps speeding up. So at 10 seconds. So notice how acceleration is always a positive number, and only at 10 does the acceleration start slowing down. So at 10, it's going the fastest. So notice positive acceleration, it just keeps speeding up even though you have like greater acceleration. It's still accelerating if it's above the axes. So at 10 it stops increasing and then it becomes negative. So at 10, this whole area here, that's when it's gone. So it's like finding the area under the curve. What's the maximum area here? And it's when it happens at 10, which is at 35 meters per second. So we figured it out in part G. So that's the fastest the object's going, 35 meters per second. J. At what time was the object moving the slowest. And then you could see down here, right, at 12 is when it was moving the slowest. Well, at 0, wait a second. So if I look at the ends, at the very beginning it was going 2 meters per second. So at t equals 0, the speed at the beginning was 2 meters per second. And then at the end, at 12, it was going 33 meters per second. So obviously at the very beginning it was going the slowest. So it was going the slowest at the beginning. It was going 2 meters per second. At the very end, even though it slowed down, it still was going 33 meters per second at the end. So the slowest was at the very beginning at 2 meters per second. K. When was the object slowing down? And so that's right here. It's slowing down not here, because notice how the acceleration is negative and the velocity is negative right here. So it's slowing down right here between 10 and 12. And it's slowing down between 10 and 12 because the acceleration's negative, but the velocity is still positive. So between 10 and 12, the velocity is still positive, but the acceleration's negative. So because the signs are different, it's slowing down between 10 and 12. All right, 37 to 40. All right, I got to watch my time. What have we got? Yeah. So I'm going to do another video for the end. So Mr. G Math over and out. I'm proud of you for doing the work. And there'll be one more video that finishes off this assignment. Bye. Till next time.